Welcome back to my tutorial. So in the today tutorial, we are going to create this kind of the design, which is this design is to create some of the feature on the lathe operation in the turning. So we will have the outer removal material here and also the inner lathe. So this one is also have the grooving operation in the face grooving and as well as the side grooving, and we also have the thread operation and internal boring and also the drilling for the internal. So maybe if you are going to see here, so I already create the simulation right now here. So let me restart again. Okay, so this one is basically the kind of the lathe operation, the external turning, profiling, and also the lathe, the thread operation, and as well as later on will be doing the internal drilling and also boring. So after you finish this tutorial, you will be able to create some of the all of the operation, and also you will create a on external or internal turning, and as well as the modifying for the tools. Let's get started. Okay, so in this tutorial, so let's open up the file. I already also provide the file on the description below. Please download. And here I will use this CNC lathe file. This will show us the shape of the overall design that I already create. So first of all, we have to remove the thread here. So in the timeline here in the down below, just right click and then suppress for the feature. So okay, like this. And then we move into the manufacturer environment. Okay, so in the manufacturer environment, so we need to create a setup. In the setup, we just right click and new setup here. So here is basically the setup for this particular part. Okay, for the machine, at the moment, we don't need to select the machine first. We want to select the setup. The setup will be the turning or mill operation on the primary spindle and also for the Z-axis. Z-axis right now is currently at the face here. So I already select the face. If not, you just select this face, then they will automatically align the raw material. And the x-axis is automatically adjusted from the direction. Okay, so the shape Z is actually where the tooltip will approach during the machining operation, and the chuck will be the location of the chuck. So if you want to move a little bit, I think we need to move a little bit for the chuck here, probably like this is more safer. Okay, and also this is the safe plane when you adjust this one, and also reflect to these parameters here. And the model, if we already have one model, so they automatically select the particular model, and then the picture, in this case we don't have any picture right now. And then the second one is the size stock. The size stock, I will choose the fixed size cylinder, and the stock diameter will be 70, and also the length will be 60. And then the model position is important, where the datum or the origin of this particular part is located. So we usually we use the offset from front, and then we put the offset probably just 1 millimeter from the offset, and then maybe I will add another length here, so like this. So because the chuck is already over there, probably I will use 75 for the 70, and this is 85 for the leave it for the chuck. Okay, so and then the machine coordinate, if we change it to 1, so it means that the G54. Okay, then click OK. This is we already set up the raw material and also for the coordinate system. And then we our first operation is turning the face. We select the face and then we need to select the tool. Okay, the tool will be, I will use this turning metric, and I will use the right hand side turning, and then this is the CNMT 09308. Okay, so this is I'm using the CNMT holder. Okay, then I will click select here. Okay, so right now currently my tooltip is snap or attached with the tooltip of this tool, because I use the Control T. When you click on the keyboard Control T, then automatically the tip will follow your cursor. This is the feature that is very nice feature, so we can examine on this particular point or particular position where this tool can reach. For example, if this one has a grooving here, so I cannot reach this using this particular tool. Okay, so it's very nice feature. Okay, but currently I just use this tool for facing and also for the roughing operation, so I will leave it like that. And the surface speed, this is the cutting speed. Cutting speed I will use 100. So the cutting speed will be depend on the material and also with the cutting insert cutting type. Okay, and if we check mark here, use constant surface speed, it means that we activate the G96 and 97. Okay, this 96, and surface speed is the cutting speed, and the maximum swirl speed is G50. Okay, so this one is 5000. Okay, so this is cutting feed rate per revolution. So for the roughing, I think I will use 0.5. This also usually we will get this number from the tool catalog or tool library. Okay, lead in, lead out, leave it like that. And right now the geometry will be the in front, so it's, I think, already select, and then the passing from outside to inside, and the compensation is in computer, and also the linking I will usually leave it like that in the default. Okay, then click OK, then the Fusion will generate the file, the operation. So if you want to simulate, we can right click and simulate this one. Okay, so this is the holder. If you want to check mark the toolpath, then the stock, if you want to see the stock right there, and then choose the colorization. I will usually use the operation, and the material will be the plastic vinyl. If you want to like it in transparent mode, the material, so we just check mark the transparent. Okay, and then if you want to stop the collision, when there is a collision between the tools and the raw material, also the jig, they will stop the operation. Okay, so like this, and I will slow it up a little bit more, and then I will click play, and this is the operation. Okay, yeah, I think it's done for the facing operation. I will exit the simulation, and then I will create another profile roughing. Okay, so I will use the same tool, and I will use the turning mode from outside to outside profiling, and to orientation I will leave it like that. The fit and speed using custom, and also the cutting fit at 0.5. And then this is for the containment of the area which is going to be roughing. So I just want to create a roughing in this particular area, and then I will slide back a little bit for this containment area, and then the front one will be 0.1 is okay. And then the offset is this is the same parameter to offset that one. And the passes will be grooving. I usually don't allow grooving, since if you see this tool cannot reach inside the groove, then I will not allowing grooving machine inside it. Okay. And I will use can cycle. Can cycle is basically using G71 on the regular G71, and also the compensation is in the computer, and maximum depth of cut will be 1 mm, and I will leave it the stock 0 0.2 in the side and 0 0.2 on the Z direction. And then this is just only the retraction area. Usually leave it like a default is okay, and also as well as the linking. Okay, and then when you hit OK, then Fusion will automatically generate the operation like that. Okay, as you can see, if we create the simulate like this, then there is no issue form. So it will be, we can have it. This one will be the operation will be good. There is no collision, and it will be safe. And I will speed up a little bit like that. This is the second operation. Okay, so the third operation, I will use the grooving. Yeah, I will use the grooving operation here. I think I will use the smaller tool to reach out this grooving. So I will use the profile finishing. Okay, and then I will select the another tool. Okay, so this tool, I will use the same, but right now I will copy this one, and then I will put it into my file here, and then I will paste. Okay, so this is the second tool, and I will edit the tool. So I will change the insert from the C type to the V type. Okay, this is the V type, and also the thickness is a little bit like that. The corner radius I will use 0.5, 0.4, sorry. Okay, so when you zoom out a little bit here, so they will see this kind of the tool holder and also the insert, right, like that. Okay, so if you want to create the holder shape, then edit it, then we can use the editing area for this one. So this one will be, I think sign diameter will be small one, 12. This is the length. This is the 16, I think. Oh, 16 is to 20. Okay, this one 20. Okay, so this tool is a little bit smaller. Okay, yeah, like this. I think I will use this one will be 18. Oh, sorry, 18. Yeah, I think it's quite appropriate. Okay, and then this is cutting data. So if I want to use 100, okay, meter per meter. This is the bitrate cutting per revolution, because this one is the finishing. So I will use 0.3 probably, and then this one is a default. Here's setup, and also, yeah, I think it's okay. And then I will accept this tool, then I will select this tool. Okay, so remember when we create here, okay, so they will create us the particular operation here. Okay, so actually this tool also cannot reach this grooving, so we will use another kind of the operation. But right now I'm going to use this one first. Okay, so this is the profile finishing. Okay, I will use probably multiple passes. Machine undercut. Allow, right now I will use allow axial radial grooving right now from front to back, and then the number of step down will be 3, and the step over will be 0.5. Okay, then let's see. Okay, so this is the profile. So I don't want to uh, create this at the moment. So I will right click and edit. I'm using the containment here. I will drag, okay, like that. Let's see, like this. Okay. Okay, so the tool will be like this, creating the profile like that. Okay. So let's see the simulation. Simulate. Okay, then I will play 1, 2, 3. Okay. So when you mention here, there is a red area here, here, and here. Okay. So this one basically see when we see here near the operation, yeah, when we click here, yeah, okay, I think there is something red going on here. It's mean that the tool is hitting the area which is, yeah, okay, you see that, yeah, let me, yeah, this one, okay, maybe in the timeline here below. Okay, so you can jump here, so we can see here, yeah, okay, and then when we examine a little slower here, here, and then here, yeah, okay, there is a collision between the holder with the raw material here. So the problem is that the tool shape here is too thick, so this one will hit first in here. Okay, this because of the tool type. The tool type is not matched for this kind of operation, so I can edit the tool. Let me try to edit the tool. So probably the holder should not be the using this kind of the holder. let me let me use the, this is the clamping in the headline. Yeah, I think this one. The if we also can use the round sign like this. So if we use the round, probably they will. Okay, let me use this height. This height I will put just a little bit more thin in here, and then let's see the result. Right click, and then you need to, sorry, it's not simulate. You need to regenerate. Yeah, regenerate like this. Okay. Then when we right click and then see the simulation, so there is an issue here. Stock on holder clearance. This one is still hitting at the moment. Okay. And then the second one also get done. Okay. Yeah. So this is the problem. Okay, we need to address this issue first. Right click, edit the tool. The holder, I think the, okay, let me use the folder. Yeah, we also can get the, yeah, this one as a compensation. If we create a tip compensation, no, I will use a tip tangent, and I think we can also create this operation like this. But it's not appropriate for the setup. So maybe I will use the smaller folder for this particular shape. Okay, when we use the smaller folder. Hopefully the problem, yeah, the problem will address this issue. Yeah, okay, like this. So there's no area. Okay, so let's continue to the grouping over there. So the area of this in front, we need to use the grouping operation, and we select the group of OD grouping. Is mean that the external grouping. Again, I will copy and then I will put it in this area, our document and our edit, because we want to edit the folder. So right now we are going to use the external grouping and right-handed, rigid lock, and also wait. Let me use which one. Yeah, this style will change to the face grouping. Okay, like that. And then the shape of the holder, I will use not a square but round, and the width will be, since there is a, I will use 3 mm, and also this one will be 0.5, 2.5. Okay, overall length I think 20. Okay, this is the tool like that. Okay, I will set, and then I will use this one. Okay, so as you can see, this should be solve the problem. Yeah, okay, like this, solve the problem. Okay, and then the operation will be just only this particular containment area, like that. Okay, then the passes, if we use the up and down, I think it's up and down is okay. Number step over, probably I will use 3 step over and 0.5. And if you use the roughing pass, I think this is the roughing pass. I don't need to use the roughing pass because I already put the number of steps over there. Okay, so this is the number of steps, 1, 2, 3. Okay, so let's see the result. Simulate. Okay, and I will play. Oh, it's not like that. Exit. Now this one, this one, because this one is on, we have to select the stock front model back group suppression. Let me, yeah, we can select the model here, which where's the activate the model, and then let's try to create the grouping. This is the base contour. This contour, this one, and I think that one. Okay, let's see. We cannot use that one. So instead, using the model, I also can limit this area here in the inner diameter. So when we limit the inner diameter, so they will contain only the area of this one. Okay, click OK. Yeah, let's see. So this is the result. Right click, then simulate. Okay, let's see the animation. Okay. Yeah, 1, 2, 3. Okay, so there is a still red area. It's because the thickness of this tool. Okay, the thickness of the tool is the main problem here. Yeah, probably because this tool is this part is too small. Then we need to adjust the Tongue width 12. I think this one also 12. Okay, 12 and 12. Then cutting width is 15. I think 10. Okay, 15. This one 15. Yeah. Okay. That's it. Okay, generate. Let's see the simulation. Oh, there is a still folder collision here. Yeah, this one. There's still a collision on the folder. Okay. So we need to again to, I think I will use the round sign for example here. And let's see. Generate. Okay, let's see. Simulate. Yeah, no issue font. Okay, so we need to use the uh, round the tool. Okay. So this one you need to be careful on the choosing the right tool. Yeah, okay, like that. Yeah, then we continue to the thread operation using turning thread. Select the tools for the thread operation. So this one using the outer diameter threading in, because I want to edit the tool, then I need to copy paste to my document here and then I'll click edit. So the insert will be the maximum thread number will be 4. The minimum will be, yeah, 3, I think, yeah. Okay. So this one, the thickness, I'll leave it like that. The profile angle will be 60 degrees. The holder, I think I will use the 12 by 12, the smaller one. And this one, leave it like that. This one also leave it like that. Okay. Then accept. Okay, I will select this one. Okay. Then I will select the geometry here. Then the containment will be from here to the back. Okay. I think this one will be enough. Okay. The multiple pass to the multiple thread using the alternate flanking. Thread pitch will be 3. Thread depth will be 1.5, and then I will edit a little bit more for the tolerance. So 5.5, and then use can cycle. And then this one is number of step down. Then let me click OK. Let's see the thread. Simulate. Make sure there's no issue found. Then I will hit play. Okay, let's see this the thread width. Let me turn off the. This one should be turned off the model. So when you turn off the model, they will show us the threading operation without the model inside. Okay, let's see the result here. Okay, so this is a thread operation, very nice shape. Okay, let me speed up a little bit. As you can see, the thread will create from along the side. Oh, I think this one has some issue. Wait, let me exit a little bit more. There is a slightly issue. Right hand or this one. Thread number should be only 1 because we use the one only thread. Okay, so let's begin. Okay, let's thread number will be only 1. Similar. Okay, 1, 2, Okay. Or okay. This is the result of the thread operation. Okay, we finish out all the outer turning operation. Now we jump back to the internal operation. Okay, let's continue to the inside diameter operation here. So when we see, then we should inspect here. The internal diameter will be 20, and also the internal diameter with this one will be 30. Okay, let's remember that. So I will use the drilling operation here. There is a drill operation. Then I will choose the right diameter of the drill. Okay, I will choose the drill. Okay, for making. So there is no drill actually. This one. Okay, I think this one for making tools. You need to choose in here for making use. The drill diameter is 20, so I will choose the 20 diameter of the drill. But usually, if you it's better that we use the smaller diameter first. But in this particular uh, tutorial, I will use straight to 20 diameter here. Okay. Then after that, I will use select the geometry. I will select this one. Okay. So when you select that one, the drill will automatically drill itself to the center. And then if you select in here, I think, yeah, this is the height. So when you see here, right now we are not drilling at the front area, so you just wrap it inside here, and then they will go finish with the feeding operation. The blue one, the yellow one is the rapid. This should be not like that for the drilling. Since we select the hole in the bottom area, then we need to create the fit height here. Okay, so this should be the, I think, the whole top selection, the whole, the both, wait, let me clearance height. Oh, sorry, retract. It's not like that. The top area here, and then this is the top height. Oh yeah, the top head will be the retract head. No, cannot. Let me see. Wait. Okay, so from the bottom head, so I need to tag mark this one through tip through the bottom, and if we tag mark this one, then you can see that the drill tip is go through inside the hole, and then the whole top we need to edit the whole top. The whole top will be based on our selection. Our selection, the whole top will be that one. So in this particular uh, selection, it means that the hole will be coming from the at the beginning of the face. Okay, then it is click OK. Okay, so just the drill. Then we can stimulate the drill. Okay, like this. Okay, so the drill operation will be, because it's a considered as a deep drilling, then I will use the packing operation. Wait, let me, this is not, don't choose the rapid drilling, choose the deep drilling. Yeah, so fully truck. So what it does, they will drill at a certain depth, and then they will retract. Let's see. Okay, like that, they will retract. Let me turn on my inspection section analysis. I will use this one. Okay. Oh, yeah, like that. So you better clearly see. So they will drill at a certain depth and then they retract. This in this particular operation, it will allow the chip coming out from the hole. Okay. Then I will exit the simulation. Okay. Let's continue with the another operation, which is turning. Wait, let me choose the turning roughing profile. But this one is using the tool internal boring diameter. Okay, so I will choose this one and I will copy and I will paste since I want to edit the parameter of the tool. Okay, so this one I will use the D shape of the tool and then the corner radius will be 0.8 is okay. Then the relief angle will be 5 degrees. This is the relief angle and this is the holder. The shank diameter will be 10 milli. Then the holder will be, yeah, in 20 is okay. Cutting width will be 12. Yeah, okay, this is the shape. And this should be the, how come it's not corner radius, thickness, custom velocity, tolerance. The holder should be, and this holder should be round. One side, right hand side, okay, rigid lock, okay. Okay, let's try with this one first. Okay, let's try with this one first. But this one should be, usually the boring bar should be rounded. Let's see. Okay, let's see the from the top, and then the operation will be like this, and then retract. Yeah, it's enough. Yeah, the retraction. See, the retraction will be. I think it will be have the. It will has the. Yeah, that one is around already. It's okay. So then I will use horizontal passes from to bottom. Don't allow grooving since there is no grooving. Use scan cycle in computer, and then I will use 0.7. Stock relief will be 0.1, 0.2. And then let's see the retraction. I think there is a clearance is not too set. Okay. This one we need to adjust the clearance. So the model stock diameter, model outer diameter of inner radius. So this is the inner radius. The inner radius will be 12, yeah, diameter, because we already drill with the 12. Okay, so that's the inner diameter. Then this is the clearance. So this one is the radius of the radius of it. So this one also I will use the diameter. Clearance will be 12 as well. Okay, so like that. So let's see the result. Yeah, there is an issue here. Okay, see, when it's retract, then it will hit this one. the holder will hit. Okay, then we need to change the holder first. Edit the tool. I think the holder should be smaller enough to get inside. Okay, let's see. Let's generate variable address. Yeah, no issue found. Then I will play the simulation. Okay. Oh, the diameter not 12. Yeah, the diameter is okay. So this one they hit. So the drill will be need more depth. Okay. The drilling operation here need more deeper in order to clearance the height. Okay, I will add 2 mm like that. Then this one I will use not 12 but 20. Okay, the clearance, yeah, maybe 16. Okay, like that. Then we simulate. Okay, let's see. Okay, yeah, like that. Okay, then continue with the profiling. One more, turning profile pixing. Use the same tool and use the diameter. I think this one is okay. Okay, inner radius. Don't allow grouping. Then the stop. Okay, just inner diameter. The diameter will be 20. This one also 20. Okay, so this is the. So how if we want to create this finishing until the drilling area, then I need to edit this value here. Maybe 16, sorry, 16, this one and also 16. Okay, so they will go through inside there. Let's see the simulation. Okay, like that. Yeah. Okay, now we use the cut off here to cut the object. So this is the last operation. The last operation will be the cut off. We will select the tool, turning. Wait, let me turning. Body grouping. Body. What's the cut off tool? This should we have to cut tool. Oh, this one, cutting tool. Oh no, not this one. For making, milling. Yeah, this should be the correct one. Turning. I cannot find the cut off tool. How about if we use this one? Auto diameter grouping. Auto diameter grouping is not cutting. Cut off tool. See? When you cut it here, cut, 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 cut. Oh, I think it's enough. Yeah, okay, it's good. Use cut off. The geometry will be that one. So they will automatically select it. Model at the back. And yeah, it's clearance like that. Okay. Use packing. So backing depth is 2 and then backing width 0.4 is okay. Then finishing pass no need. Edge break no need. Yeah, this one. Okay. Then we see the overall operation, right? So we already finished the cut off. Let me see first, then okay, like that. Good. Then they will cut off. Okay. So but before we did the cut off, I think we need to address this one first, which is grooving, turning a groove. This is single groove. I will use the same tool and I will address just this one. I think it's not using the groove. I think using the turning chamfer. Yeah, turning chamfer is select. So then select the chamfer. Yeah, that one. Let's see. The chamfer width would be, I think it's 0. Let's see. Let's see what the here. Then let's simulate. See in here. Okay, good. So this is the chamfer, and then the next part will be the grouping. Okay, let's see its overall operation. Simulate. Okay, this is half analysis, so I don't want to put it half, and then I will play overall simulation. Let's see. So this is the roughing operation with the CAN cycle G91. Okay. Sorry, not G91, G71. Okay, finishing. Yeah, finishing. Then face grooving. And then threading. Automatic model. Threading. Operation. Then drilling. Turn on the analysis. Okay. Okay. Then internal roughing for the diameter. This is internal roughing and also finishing as well. Then creating chamfer. Okay. Then cut off. Okay, finish. Okay, finish. Yeah, finish the overall part is already, yeah, like that. Okay. Thank you for watching this tutorial, and please give like if you like this tutorial, and also if you want to ask something, then just write on the column description. Thank you. See you in another tutorial. Bye.